So with this one we are saying one interface should be in the one VLAN only. We cannot put more than one VLAN. Then here this cable is going to carry the traffic for both the VLAN. How they are going to carry? This F0 by 5 of switch 1 is going to carry the traffic to F0 by 5 of switch 2. Means traffic is going from switch 1 to switch 2. So if I put this F0 by 5 in VLAN 1 and here also VLAN 1, it is going to carry VLAN 1 traffic. By default they are in VLAN 1, so they are going to carry the VLAN 1 traffic. But now I have here VLAN 10. So if I put this in VLAN 10 and if I put here VLAN 10, then they are going to take only VLAN 10 traffic. They are not going to take VLAN 20 traffic. If I put this here VLAN 20, it will remove from the VLAN 10, it will go to the VLAN 20. Then they are going to carry the VLAN 20 traffic, not the VLAN 10 traffic. Okay, or any confusion? But in the company, in the real environment, we need to carry both the VLAN traffic. So how we are going to carry that one? To carry that one, we have the concept of trunk. We are going to configure here trunk, who is going to carry the multiple VLAN traffic. So right here, what is that one? We have the interface F0 by 5. Okay, this is the interface. We can write switch port mode trunk. Okay, and then I will copy this command we need to put here also and here also. So here also we have the F0 by 5, here also we have F0 by 5. So we will put here also same thing. Then they are going to carry the multiple VLAN traffic. Okay, any confusion, any doubts, anything? Okay, here if you see, this is F0 by 5. Example, if I go here, I will say interface F0 by 5. Here I will say I will move this interface, this one interface in the VLAN 10. I move this in VLAN 10 here. I make this in VLAN 10. Here also I am making in VLAN 10. Example, interface F0 by 5. I will write switch port axis VLAN 10. I make this both interface in VLAN 10 from here to here. We need to wait some time. If you see the color change here, ambert color, if you don't want to wait, just press fast forward in the packet tracer. In real scenario we need to wait. And if you want here, example, first let me assign some IP here. I will put here 192.168.10.1. okay, and here this computer I can assign 192.10.2. and now I want to ping, so it will work. Let's see here. I will say ping 192.168.10.2. so it is working because this port is in VLAN 10, this port is in VLAN 10. But if you see here, example, this computer I will assign the IP 192.168.20.1, and here if I assign the IP this one 192.168.20.2. okay, and if we ping from here 20.1 to 20.2, it will not work. If I write here ping 192.168.20.2, it will not work because here we put this port in which VLAN, we put this port in VLAN 10, so only VLAN 10 traffic will go. If you want, we can put like this continuously. If you want to send the ping, we can put like this, so continuously they will send. So this PC, that is VLAN 10 traffic, is going from here to here for VLAN PC, that is working. But if you check here for VLAN 20 traffic, it is not going. It is giving the error because interface can carry only one VLAN traffic. He cannot carry more than one VLAN traffic. So if VLAN 10 is working, VLAN 20 will not work because we have two switches. So from this switch to this switch, they will not carry. If you see, it is not working. But if I change this interface, example, I will say I will change this switch port axis. I will put this in the VLAN 20, and same thing I will go here. I will change here also switch port axis VLAN 20. Okay, both I put in 20. I can do fast forward and I can check here. It will start going the traffic from VLAN 10. If you see till here VLAN 10 traffic is working. After that it stopped because I moved this port from VLAN 10 to 20, this one and this one. And here if you see, before it is not working, before this is not working, after that it is started. If you see, before it is not working, when we put this interface in VLAN 20 here and here, it is start working. But this is not practical solution, because in the company we need to send all the traffic, VLAN 10, 20, 30, whatever VLAN we have in our company, we need to send all the traffic to go through from one switch to another switch. Like we cannot do configuration. Now VLAN 10 guys are talking, let's put in VLAN 10. Now VLAN 20 is talking, we should put this in VLAN 20. This is not practical. To overcome these types of issue, we are using the concept of trunk. Configuration is simple. We will write like this: switch port mode trunk, like this. This command we will put, and here also we will put that same command, switch port mode trunk. We need to go under that interface. Under this interface, whatever interface is connecting between the two switches, and we need to do. After that you can check, it will start working. It will take some time because we are having here ambert color. In the real scenario, we need to wait. If you don't want to wait in the packet tracer, you can press fast forward. So it will be green. If you see VLAN 10 traffic is going here, VLAN 20 traffic is going. Both the traffic is going same time. Before it is not working, but now it is working because we make this interface as a trunk. How we make? If you see here, this is the command we use to make that interface as a trunk. The interface which is connecting from one switch to another switch, we need to remember, we need to make that interface as a trunk. So here I make trunk, here I make trunk. This is a command we use to make as a trunk. Trunk is going to carry the multiple VLAN. And here how the switch know that one means we can verify that one. How they are putting the tag, how they are removing the tag, we can verify also. So what I can do here, I can stop here this one. Okay. And here also I can stop here. And if you see here, what I can do here, I can go to the simulation. I click the simulation, I take the packet from here. I am going to send from here to here. So this packet, it will come to the switch. And if I open this packet, if I check whatever packet is going into the switch, inbound PDU means into the switch. So whatever traffic is going into the switch, if you see, nothing is mentioned here. But if you go here outbound, you can say here this is written here. Let me repeat again. This PC is sending some data to other PC. When it come to the switch, we can select this is into, means the packet before going into the switch. Nothing is mentioned here. But when the packet is leaving or going out to the switch, you have here 00A. So it is written in the hexadecimal. In hexadecimal, A is nothing but 10. If you go to the calculator, if you write in the, what we can say, hexadecimal, here 10. If you write what we can say in the decimal, sorry, if you write A in the hexadecimal, if you write A in the decimal, what you have 10. If you see in the hexadecimal, if I write A in decimal, it will be 10. So if you see here, this is a packet. When packet is coming into the switch, we don't have any tag. But when packet is leaving the switch, we have the tag. Because why I am saying leaving the switch? Because outbound PDU means whatever is going outside, whatever is packet or frame is leaving the switch, that one is having this tag 00A. A is nothing but 10. If you see hexadecimal A, it is written in the hexadecimal. This is in the hexadecimal. If we convert in the decimal, this is a 10. So this switch is saying this packet is coming from VLAN 10. And he is putting the tag here and he is sending to the other switch. Because we can ask how this switch know that VLAN 10 traffic, this packet belongs to VLAN 10. This packet belongs to VLAN 20. How this switch know? This switch know that one because the other switch is putting the tag here. In this tag he is saying that one, this belongs to VLAN 10. And when this packet will go to the other switch, this switch will see that packet. Okay, this switch will see the packet. This switch will see the packet. He will open. He will say, okay, whatever packet is going into the switch, it is having the tag saying that one, this packet belongs to VLAN 10. And switch will remove this tag and he will send to the VLAN 10 PC. If you go here, you can see they remove. We don't have any tag. Here if you see, you have tag here. But here whatever is packet is going out to the switch, you don't have anything. So after that, this packet will go to the VLAN 10. Okay, so same thing they will put. If I send from here to here, this packet will come here. Okay, and they will check here. Inbound nothing is present here, but outbound they put here 14 because 20. If you go here in the hexadecimal, if you write 14, what is the meaning of 14? Let me put the 14. If you see in hexadecimal, 14 means 20. So this one is saying that one, this switch is putting here saying that one, this frame belongs to VLAN 20. That's why they put 14. And when this will go here, switch will remove that one, and here they will check, okay, this belongs to VLAN 20. That's why they put 14 here, and he will remove that one, and after that he will send to the VLAN 20 PC. Any confusion, any doubts here? So what we done, we use the trunk. Yeah, we use the trunk in between. So trunk is going to carry the multiple VLAN traffic. So this is a basic lab. I will give you one assignment. You try to do that one. Tomorrow we are going to discuss in detail about the trunk. We have the two protocol, ISL and 802.1q trunking protocol. So tomorrow we are going to discuss that one, and we are going to do some more lab.